Hi, this is a summary of Redox, and it was prompted by a question that Victoria asked in class when we were talking about oxygen or hydrogen or oxidation numbers, and which one's oxidation, which one's reduction. So I thought I would just summarize it in one slide like this. So what we can do is we can have a look at a table. We can create a table where we have oxidation and reduction as two columns. So we can make a table like that, and first of all we can think about in terms of oxygen. So if we were to add a oxygen atom to a molecule, then it's pretty certain that that molecule would get oxidized. Right, so if we add oxygen, then it's oxidation. If we remove oxygen, then it's reduction. We can also think in terms of hydrogen. If we add hydrogen to a molecule, then that's commonly known as reduction. Right, so if we add hydrogen, that's reduction, and if we remove hydrogen, the corollary of that is that we're actually oxidizing the molecule. Okay, we can think in terms of electrons, as in oil rig. Yeah, so oxidation is loss. Alright, so we can put loss in here. If we're losing electrons, then we know it's being oxidized. And if we gain electrons, we know it's reduction. And lastly, the oxidation number. If the oxidation number of an atom is increasing, then that's oxidation, and if it's decreasing or reducing, that's reduction. Let's put reducing there, so it's quite similar to the word reduction. So if the oxidation number is reducing, like say for example going from 0 to -1, you know that that atom is being reduced. Okay, so there's a little summary for you. I hope that helps. But before we move on, what I might do is just do a few examples. So for example, if we start off with a carbon atom, and we turn that carbon atom into carbon dioxide, we're adding oxygen and therefore oxidizing the carbon atom that we started off with. Let's just draw carbon dioxide along with the electrons. All right, so you've got a double bond to one oxygen, and it's a planar linear molecule, so we've got another double bond to the other oxygen there. And let me do the electrons in red. Right, so we've got a little electron here, carbon electron in there, carbon electron, and let's say black electrons can be the oxygen electrons, like that. Okay, so according to the electron transfer theory, then all of those bonding electrons are assumed to be the property of the most electronegative element. Alright, so this carbon has none of those electrons. Alright, so it started off with 4, and it's now got none. So its oxidation number is going to be 4. Alright, so it's going to be +4. Alright, whereas it started off as 0. Alright, so we can see that that's been oxidized because you've added oxygen in one term, but in terms of looking at the oxidation number, that oxidation number has increased from 0 to 4, and so you can see that that is consistent. Those two methods of looking at oxidation are consistent. We could take another example. Why don't we have a look at methane? We're going to start off with carbon, right, and then turn it into methane. So we've added hydrogen, so we think that according to this table, that's reduction. But let's have a look at the oxidation numbers. So we know that this oxidation number is 0 to start with. But what's the oxidation number when it's in methane? So let's draw out the molecule. Let's draw out the molecule. So we've got carbon with 4 bonds, 2 hydrogens. Like that. Let's again put carbon's electrons in red. Right, so we'll have them on the side of the bond. And let's put hydrogen's electrons in black. Looks like I've made those crosses as well. Okay, so now what's the most electronegative out of carbon and hydrogen? Well, it's carbon, 2.5 versus 2.1. Right, so carbon is assumed, according to the electron transfer theory, to hog all those electrons as if it's an ion. So that has gained 4 electrons, and so its oxidation number has gone to -4. And so you can see that that jump there is a decrease or a reduction in the oxidation number, and so these two are consistent as well. There we go. So hopefully that's helped.